Alright, so for the next question, I thought it'd be appropriate to tackle the topic that I messed up on my interview at Microsoft. So it's intervals. I don't think it's any of these questions exactly, but I guess we can start with this one since it's easy. So given an array of meeting time intervals where intervals I equals start end, determine if a person could attend all meetings. Okay, so basically we are trying to see if there's any overlap. That's what I understand. So for the constraints, it could be 0. The length could be 0. Intervals.I, so every interval has 2, and the start could be at 0, and the end can be very big. Okay. So one thing to think about is that it's not sorted. That's the first thing that I'm thinking about. If I were to draw, so I guess to just simply conceptualize what's going on, if we have a number line, this is 0, this is n, this is whatever, this is 100, whatever. There are going to be these intervals. Alright, let's say this is like 4. Alright, there's going to be these intervals. We need to see if any of them overlap. So if you have an 11 here, and this is a 18, then that is going to make it false. But if it's here, if it's 13 instead, then we can attend all meetings. So we need to find a way to check if there's any overlap. And the way we do that is by so the brute force way, just like if we're not thinking about efficiency at all, then the brute force way would be to check, compare like the start and end of every single integer with every single interval with every other interval, and that would result in a n squared. Right, like you would start at 0, you would check, you basically say like if this one is like if 5 is before, if the start of this one is before the end of this one, and the end here is also before, like is after this one, then you would have an interval, and then you would kind of just compare each one. But then like you compare this one to this one, and then this one to this one, it would be n squared. But I think it would be more efficient if we did not have to sort, if we did not have to compare every single one. So I'm thinking it would probably be faster if we could sort. So if we just do intervals of sort, now everything is going to be sorted by the first number. So now this one's gonna be 2, 4. So I just want to visualize something that I just want to like put into consideration, see how it would work. So what would happen if we had something that's here, can we have something here that's like super long? And then, okay, no, so anything that comes before, it'll intersect before the next one. So if this is 1, this is 2, this is 2, and this is 3, doesn't matter where this one is, it can be very close. If this one intersects, this one will for sure intersect before it, so that way, like by going through iteratively, we won't miss anything. Okay, so intervals dot sort, and now we go through each interval. So for interval in intervals, we just need to see if the start of the second one is smaller than the end of this one, right? Okay. And we'll just set prev as like -1, I guess. So we'll say if interval, because we're gonna have to store previous to compare it, right? So if interval, if interval 0, so if the start, if interval 0 is smaller than prev, then we say return false, right? And then we do prev equals interval 1, right? Prev is just the end of the previous one. And is there anything else we need to do? If for interval in intervals, and by the way, by setting it to -1, since we know the value must be greater than 0, it'll always, prev will always be smaller, so we don't have to worry about this for the first case. So for interval, so we'll compare this one first, and let's do a scenario where it doesn't overlap, or we can just keep this one, right? So interval, okay, so we won't check that first one, but by the way, so edge case, we should think about, I'm just gonna write it down, edge case, intervals dot length equals 0. All right, just something to think about. So for intervals in intervals, if interval 0 is smaller than prev, okay, and then yeah, we return true if we never get to that point. So here, so we would start by just checking this -1, right? So intervals 0, which is 0, compare it, but previous is smaller, so we don't do it. So now if we just have like a prev here and interval. So now prev equals, so at first prev is -1 and it was 0. This was 0, but now this is 0, and interval is now whatever this is. So let's say this is like 2. Interval 0 is still greater, so then we set prev to interval okay, wait, sorry. We need to set prev, okay, wait. We need here to set prev to like whatever this is, so like 10. Alright, so we need to set prev to 10. And then prev, right, because we're comparing 1. And then we're gonna compare prev to interval this, which is like, let's say 2, and it's gonna return false. Okay, good. So what if we change this? What if we change this to 1? Okay. And then, so we're going to compare 1 and 2, it's smaller. So we set this one to 3. Right, we're setting this one to 3, and then interval, we'll say this is like 4. Alright, so looks like this logic is correct, but we need to account for the edge case. So if intervals dot, if len intervals equals 0. Well, I guess it's just like, I don't know what, okay, we'll just create a test case here, and we'll say the interval length is nothing, equals 0, return, just say 10 true, because I guess they, okay, so we actually don't need this then. Nice. Alright. And for this one, the time complexity is going to be n log n, and because of the sort, and the space complexity is going to be I think constant, because we're just setting this prev, we're not taking out more space, we're just continuously changing it, and we're just referencing these the array that already exists. So so time equals O of n log n because of the sort, and then space equals O of 1 because this is constant, we just have 1. Unless sort, no, that just sorts it within the same interval, within the same array, right? Let's see. Yeah, n log n. Yep, nice. I guess before, I just want to see if there is a better solution than n log n. Okay. So they're saying possibly more space complexity, but it just depends on the actual sort. Um, okay, nice.